to our training. Welcome back. And I hope the tea break was nice. Was it? Wave your hands if you had a wonderful tea break. Oh, awesome. Yes, that of Mr. Aknok is enough. All right, so we'll have to welcome back on stage now to continue the later parts of super pave and balanced mix design. So we'll be bringing back on stage to have us for another 30 minutes Engineer Dr. Patrick Amor Becker. Please put your hands together for him once more. We stopped him. I hope I tried. No, I did. I got information. Bekwe, yes. Thank you.
All right. Thank you very much. So can we continue? I know normally after food is difficult to concentrate, but I'll do my best. This is the break. Okay. Can we have the projection? So, all right. So we're going to start the mix design, mainly going through the design process. And I'll keep referring to some of the things that we talked about earlier. At least now we have a clear understanding. So, in principle, let's say that the design process, we are looking at 7 stages. If we are dealing with super pave mix design procedure. So the super pave mix design procedure. And I want to put it once again in context. Here, we are dealing with only the mix design of the asphalt. As we reflect on it, it's a design. Do you understand? And we know the importance of design. I'm sure later on Dr. will talk about actual construction, placement, what really happens after you've done the design. And so the design is only to help us to get the right proportions. 1, the right binder, the right aggregate, and the right mixture. That's all that we are doing. Whether you want to add some additives, whatever, now there's rubberization of the asphalt and all those things. But at the end of the day, you need to go to a batching plant, batch them, place them, basically mix them on the field, and then compare between what you have done here and what is on the field. And that is very key. Sometimes people say, yes, we've done the design, it's perfect, and then they forget about what is actually going to be placed on the field. If you don't monitor all the way, and Doc Amin will go and take us through that. But so let's look at the 7 steps in simple. So we select the aggregates. Now we know how to select the aggregates, select the asphalt, prepare a sample. So we are in the lab. We are doing mix this thing. Conduct what? Certain performance tests on the mixture. Do you understand? Then calculate the mix densities and voids. So remember, we'll go back to the phase diagram that I talked about. How much air is in it, those properties that we saw, we need to determine them. Then determine what is the optimum binder content. Because let's think about it also this way. When you have too much binder, I think yesterday Doc talked about what will happen. Yes, bleeding, yes. Yeah. So you need, and when you have so much less of a binder, what will happen? Cracks, what again? Okay, so we need an optimum that will help you get a stable, a well-dense asphalt that will perform very well. Okay, then you will do an evaluation, and as you know, the moisture susceptibility of your mixture is very key. So you do that in normal Marshall test to evaluate the moisture. So just those are the processes that we're going to go through. So, well, we've looked at aggregates. I've talked about all these things before, so I'm not repeating, but the normal test, your absorption to get all those proper LA, your soundness test. Do you do soundness test over here? Which one, sodium or magnesium? Which test do you normally, is it sodium soundness test or the magnesium? In the lab. Magnesium, that's, most people use the sodium soundness test. I just wanted to find out. So this is what we talked about earlier on, but once again, remember your control points, your aggregate properties, and remain within your control points. Now, and avoid the restricted zone. I talked about this earlier on. And like Prof said, if a mixture falls within your restricted zone, you will have problems. And basically, with, you said compaction of the mix, but also even rotting challenges that you are going to have. So just avoid the restricted zones. So what you do in the lab typically is to do a minimum of 3 mixes. Okay, what we call a trial mix, and you start with it. But remember, all your 3 trial mix should fall within your envelope that we have talked about earlier on. And so that's the first stage in selecting your mix. I've talked about it, the various sizes. Remember, we talked about the nominal maximum size and the various sizes and the control points and all those things. They are in the notes, you can look at them. Then you now select the binder. The first one, we talked about the binder test and the things that you need to do under the binder test, so I'm not repeating. Then prepare your sample. So you need to prepare your sample. Basically, you've chosen your PG grade from your binder, you've picked your aggregates, and now you need to prepare the various samples. And so, let me say there are mixing procedures. Every state, or sometimes they give a recommendation on the way you are supposed to, the temperature, mixing temperature, and all those things have been given. And you try to now simulate, one, the short-term aging, we've talked about that, and then the long-term aging. So now, the only difference, or the major difference, not the only difference, that you will have, that the super PAVE, if you want to adapt it in this country, is the introduction of the gyratory compactor. You have it already? Oh, okay. The gyratory compactor? Okay. Yes. So the gyratory compactor, and because I'm sure you eat fufu, we are used to, we know gyration, you know, the way we do fufu, you do this, am I right? Then, that's gyration. Am I right? Then you do this. At an angle, you turn the fufu. Now, what are we really simulating? In a way, we are simulating how the asphalt, the loads that come on it on the field with the confinement. Okay? So, remember in Marshall, how do you do? It's a vertical load. Do you understand? Here, it's not that vertical. So can you click on the link over there? There is a video. I asked the media team so that we'll look at a video on the gyration. If you can play it. Are you ready? Okay. So, I'm saying fufu and all those things, but the practical, so there's a gyration angle.
NIHTE Gyratory Compactor is designed and manufactured with the latest technologies in accordance with the SuperPave system and complies with ASTM, AASHTO and EN standards. It has been developed for the SuperPave asphalt mixture design to avoid premature deterioration of asphalt pavements. The machine is used to simulate the real compaction conditions under actual road paving operations to determine the density and compatibility of hot mix asphalt and to prepare cylindrical specimens for Marshall and AMPT tests. NIHTE Gyratory Compactor is a superior product. Is developed following the time-proven principle used on the original Texas DOT gyratory compactor. The principle is dependable, easy to validate and widely understood. Highly sturdy construction that ensures the gyratory angle is maintained under all load conditions and is designed to offer a latest generation product at an unbeatable price-quality ratio. The machine is equipped with an electromechanical rotation combined with pneumatically operated vertical pressure, standard or perforated molds for cold emulsified asphalts, an integrated worktop with pneumatic specimen extruder, fully integrated control unit based on Windows operating system with a full color touchscreen display. No PC is required thanks to the onboard control unit. Intuitive software for single test data processing or statistic elaboration of multiple tests. A direct connection to internet for remote technical assistance and software updates. An unlimited memory storage with 2 USB hosts and 1 SD card slot. 5 good reasons for choosing our product. Highly rigid steel frame with a gyratory motion generated by an eccentric high precision system. Accurate setup and conservation of the gyratory angle, adjustable from 0 to 2.4 degrees. Automatic control adjustment and storage of the angle and the vertical load in compliance with EN 12697-31 and AASHTO.
All right, thank you. I think now, at least we now know how the gyration is done. If you can go back to the slides. Now, when you now have the mix and you now go back and conduct the test. But so with the gyration, you can simulate 3 things. One is, so this is just a gyration compactor. Let me go forward. So you can simulate the initial, you see, let's step back a little bit. In the field, when you prepare asphalt and you come to the field and you are placing it, what do? you normally will compact it. Am I right? So there is an initial compaction where you use your roller, okay? Then we have, when it's being used, there's also some repetitions that it will go through, the asphalt will go through, then the long term. Now this is able to, in principle, simulate these processes, okay? So you will have your N initial, that's the number of cycles, okay, or repetition of load, N initial, N design, and the maximum that it can ever take. And so when you get it, these are the results that you get from your gyration. I mean, the software that we just saw, I mean, the video that we just saw, there's a software print that it will come out. So the N initial is the number of gyration used to measure the mixture compactability during construction. During construction. Then we have the N design used to produce what is expected, what will help, I mean, it will undertake during its use or during the field operation. Then N max is the maximum number of gyration that you get. So these are three results that you will get from the SuperPave gyration compactor. Now, going back to it, I just want to emphasize some few things here. This is the weight, the pressure range, the gyration angle that you can use, and then the speed of the gyration per minute. And you can simulate all this within your gyration compactor. Please, is that clear? Now you have these results. What do you do? So let's go forward. So this is basically what I was talking about, the N max, N design, and then the N initial. Okay. And in each and every one of them, you then determine the air voids. So now we can use this to determine, based on the load category, so the number of easels, if it's less than this, so it will give you a chart that will show that if your easels are maybe less than 3 million, these are the possible, and those values are given over there. Between this range, these are given. So you have an idea of what the number of gyration, or basically load repetitions, that your asphalt can take during performance. Now, at this stage, we will now pick the asphalt and conduct some performance tests. But based on this test, remember, let's go back. You see, we can now determine some properties where we started from. I showed this earlier on. Remember this. But we can now determine, based on the miss, these properties. Now we can determine your air voice, you can determine your GMB, GMM, volume, VFA, VMA, all those properties that we were talking about can be determined after this. So we now will be able to determine the optimal asphalt content that we need to use. What will be the air voids? Because you remember this test, from there we can determine the air voids. What will be the air voids in performance? And then we would normally take some samples and test them. So we'll do a battery of tests, which is going to be performance tests on now the samples that we've taken. Please, is that clear? I'm taking my time so that you picture the processes that we'll go through. And that is very key, because we now want to simulate initial use and long-term use and how your asphalt is going to perform. So now we are at this stage. Let me move forward. All right, so we now conduct performance test. So as we do in your normal Marshall or HVIM tests, there are new tests that are being people do, like the IDT, the indirect tests on. Do you do IDT here, where you take cylindrical this thing and look at also the number of cycles and all those things? So and there are more tests. Another example of test is the cylindrical, the half semicircle test that some country or some states actually use. So there are a lot of battery tests basically to test the stability and flow as you do in your normal Marshall mix design. So these are performance tests that you conduct on them. Then I've talked about examining the mist densities and the air voice that we just talked about. Then you use that to select the optimal moisture content. So remember, you started with different binder content. So optimal binder content. So maybe you started with 7. Yesterday, Prof talked about US 5 or so. We will normally start even below that, 4. So you start with 4, 5, maybe 6 different binder contact with different mixtures, and then determine the optimal. Maybe your optimal may be 4.5 or 5.5 or 6.5 or whatever, 7.5. That will be your optimal binder contact. Remember, yesterday there was a question, and I don't know whether you got it when he answered it. You realize that the binder content is very small in asphalt compared with the entire mix. But whatever goes into the aggregates, which is dependent on the porosity of the aggregate, is even smaller. So we are actually dealing with maybe another 10% of that small content. I don't know whether you get me. So when we are seeing 4.5%, the percentage that is absorbed is maybe 0.1. I don't know whether you get a picture. So we are dealing with 0.1, or let's say 0.2. So it's 4.3 that is actually being used for coating and all those things. It's only 0.2 that is being absorbed. So just think of it that way. And you mentioned it rightly yesterday by using percentages, but I just want to bring that across. So that is the next stage in selecting the optimal, and then you now deal with the performance evaluation, moisture susceptibility, and the test that you do on Marshall. So in summary, these are the procedures that you use in SuperPave. It's an improvement, and I want to emphasize a few things that we've learned over here. The difference between the conventional and the SuperPave mixes. 1, SuperPave specify highest and lowest service temperatures. I think that one we are all clear about it. The conventional does not. But the binder test, you do a lot of tests on your binder. Remember, we looked at you basically do the conventional, then you do the rolling, the short rolling thin oven terms, that's the short term age, then the long term, the PAV test. So you are now dealing, the test on the binder becomes very costly. I hope you get it. Then the next thing is, the space is not well established, and states even keep on varying it, making modification. But we know that is a superior performance test. People are still improving upon it, and we can start from there. Super PAVE specify properties after long-term aging in service. Conventional does not. Super PAVE specify load, I think is just a repetition of this. Conventional does not. So that is the advantage we have if we are using Super PAVE. There are more things that we can read about. This is more of exposition, and the various tests themselves, how we conduct them. And nowadays, I always say, luckily, because of YouTube, you can look at some of the videos of the various tests that we've talked about on YouTube, how they are done. But I believe as professionals, what we should know and understand is why we do them. Why we do them. The moment and I believe most of us are engineers or engineering technologists or here, the moment we just do the test without understanding, then we become technicians, or let me say, even robots or AI robots are now smarter, but yes, but we should understand the purpose of the test and why we should do them. Not because, and once a while people consult me on geotechnical issues and other things. And I'll give you an example. They brought me some lists of tests, and people were from Brazil. And they said, we should do this. And I've heard also that's also from Chinese. These are the tests that we should do. And then we start, why do we want to, in our country, this is what we do. So we should just do this test for us. And most often, when you now explain the purpose of the test, why you think maybe this one may not be necessary for these conditions, then they understand. So I want us to understand Super PAVE from that direction and the things that, the implication of the test that we'll do. Now, we are not done. I'm almost done, but this leads us to the issue about balanced mixed design. Super PAVE is a mixed design. What are we trying to do? We are trying to ensure that we deal with rotting and also cracking. Before I go ahead, this just come to mind. What are the types of rotting? There are two main types of rotting. What are they? So, rotting. Did I say cracking? No, rotting. Okay. So, Prof has already said it. Yeah. So bottom up is what? It's mainly when it's possible that your base, okay, has a problem, and that is causing the rotting. So we call that what consolidation what? Rotting. Do you understand? Then it can be also just at the top, instability of your mesh. Instability what? Rotting. So due to shear failure within the top. So it just came to mind. I said, and then cracking. There are various types of cracking. Am I right? We can mention a few. Okay. Yes. Okay. So they are longitudinal crack. And we should know the causes of the defects. So whenever young engineers come to my office, one of the things I teach them is defects identification. And the causes or the possible causes of that defect. You should be able to know, like she rightly said, if there is an alligator crack, you should be able to identify that this is an alligator crack, and these are the possible causes. Okay. Now, in balanced mixed design, what they seek to do is basically, let me say, optimizing the mix such that you are able to, and maybe you talked about it yesterday, balance both ratting and cracking, deal with this thing. What is the most common, the commonest type of defects that you have in Nigeria? Ratting. All of them. All of them. All right, that's just by the way, but I think sometimes when you have countries with very high temperature, if your mixes are good, then you have a lot of ratting being an issue because of the temperature. If you are, for example, if you are not using the super pave, you don't have the right super pave grade, then you should have that challenge. We can design for most of the cracks, especially the temperature-related cracks. Okay, so in balanced mix design, what we are doing is we are trying to find the best mix that will be able to what? Resist both cracking and ratting. And I think tomorrow when we talk about MEPG, there's this also issue about getting what is an acceptable ratting and what is the acceptable cracking, because sometimes no matter what you do, there's a minimum rats that you have. But what is acceptable? Is it, for example, 20 millimeters? If you have 20 millimeters, is it still okay or it's not okay? So these are issues that you deal with. But now there are tests that can be done based on your mix and place them more in the laboratory or in the field, but not, when I say field laboratory test, let me put it that way. So you've heard about accelerated pavement test. Accelerated pavement test. Okay. Oh, no, if you've not heard, you can read about it. So accelerated pavement test. They place the pavement is more of a laboratory, but large-scale laboratory testing. And then they test, put some loads on it, the same environment, sunshine. They simulate everything that will happen to the pavement in use. But let the pavement go through this quick number of cycles to know how it will perform in future, and what are the cracking, what are the ratting that will happen in that future. So you are simulating it so it's able to tell you maybe within a month or 3 months what will happen in 20 years. Wheel tracker, okay. Wheel tracker, okay. So you have it here. So no, you can explain what you have and okay. So how long do you so typically how long does it take? No. For a particular test, a month? Okay. So that's what I'm saying. Depending on the number of years, your design years, and what you want to see, then you simulate environmental conditions. Do you simulate the environmental conditions? So now there are radiations and other things that you apply on your pavement to show, because it's the oxidation that we talked about. I think you simulate the same thing, UV radiations and all those things. And then you see the performance that it will undertake. So there are various tests, but at the end of the day, it's not just a rigid. So the long and short of all that I want to say under balanced mix design It's not just a rigid following Marshall or following Super PIV, but now dealing with performance and trying to get a mix that will meet your performance needs. Please, is that clear? Is that clear? That is the whole idea of the balanced mix design. I will want to pause here. And now, I know the next section, Prof will talk about it. Quality issues about quality control, quality assurance, and then the optimum binder mix that you should do. I'll pause briefly, and if there are any pertinent questions, I know someone has already come to me that he has 3 questions, and I was like, okay. All right, on that note, thank you very much on that, and let me have the questions.
Told us that the Marshall test, I think my voice is audible enough. Okay. It's okay. Okay. Listen, I should use it. Sorry. Thank you so much. So, you told us that the Marshall test is different from the gyration, the way it is done. Now, what about the number of gyration? Because we need to know the number of gyration. Does it depend on the design of the traffic level or the mix type? That's my question. Because I know all the key parameters has been given, but how long it varies? Thank you so much.
So we have one other question. We'll quickly take the questions so you respond at once.
Thank you. My question borders on the factors that you said affects the choice of aggregates. If I recollect very well, you made a mention of 3 things, but the one that I really want to talk about is the one that I feel that as engineers, we may not really have total control over. And I think that by sharing this, if there's anything you really want to do as an institution, you can help us out. On the issue of aggregates, you talked about consensus aggregate properties. You also talked about sources. It's the issue of sources that I want to talk about. You see, I see that particular factor as one of the key things that is affecting us here in the part of the country. Because, like we really agreed, rotting and cracking, they are the problems, and there are problems. So, and I really want to say that the source of our aggregates, aggregate being, the major constituent of the asphalt, the source, for example, in my state, they can just one day wake up and say, no, we're no longer using this particular asphalt or plants. You say, why? You say it's because, can't you see the asphalt they brought there? The road somewhere failed. So it's most of the time it's like these things are done after the damages have been done. So, but when you talked about data collections being our major problem in Africa, I think that if you are able to have a good way of mapping all our sources, especially asphalt plants, and we have a regulatory body from the center that helps us. Because you see, all of these things that you are saying cannot be properly handled at our individual levels. We need people, we need a backing, a strong one. I want to give an example of my where I work. I work with World Bank projects. I really want to say that one of the things that have helped us in the past years in my state is the backing that we are receiving from the World Bank. The state will tell us that this is how we do it. You understand? Then we'll come back and tell them that this is World Bank standard. This is what World Bank wants. And from our federal office, they gave us the necessary backups to be able to achieve that. So I'm saying that if it is possible for you from the center to help us monitor the sources of our aggregates, surely looking at the amounts of money that is involved in asphalt and all of that, so that we are able to conquer the issue of aggregate sourcing. Thank you.
Because of memory, can I deal with that? All right. So let me rather start with this, the last one. You are totally right. But I always say, this is my personal opinion. I think part of the question is for either NSC or this thing. You see, when it comes to these things, it's easy to point fingers at people. Oh, let these people do it. Sometimes they even don't know why. So you, for example, where you are working, if you can start collecting data at your level and show that this query, this is the properties of the aggregate. We use it at this location. Maybe this is what happened. And even build a 5-year data. In 5 years, you'll be able to tell a story. There are young people who are in the university, come to do internship at your place. You can use them to be collecting data. Now there are GIS and all those 10 maps over there. So the next time you meet a top official, you can just even show them the maps. That at this particular query, anytime the absorptions are very high, their toughness are very high. That is when they will start listening to us as professionals. For me, that's what I always believe, that have evidence. And I always use a personal example. When I started, I was 22, 23 years in the northern part of Ghana. I don't know why, I started collecting data in Access about bridges in the north. And one day, and these are possible bridge locations, we got some visitors from DFID, UK, and they were actually coming to do the same thing. Then I told them that, I've been here for 1.5 years. I've collected data for my area because I was an area engineer. I've collected all the bridge locations, and that was the time GPS had started coming, 2002 to thereabouts. So, you record the GPS, you come back and type in very much. But they were amazed that I had all this information on my desktop. At that time, I was using a desktop. I had it on my desktop. And so immediately, Rachel Flannery, the lady who was responsible, actually called my boss in Accra and said that someone in the north has started doing this. And so she thinks that we should replicate it in the entire country. So that's my personal advice. Let's start something and listen. And how do we start? So, like you can build a LIMS, Laboratory Information Management System. That's what I call LIMS. You do the test, link it to projects, find a way of linking it to location. Okay, this aggregates, this binder, these are the properties. but this is where we use them. You'll be amazed that within 5 years, people will now start consulting you, and you will now start learning from your data. That's how AI and all those things, it's just data, having the data, linking it to performance, and then learning, oh, okay, is this same contractor? But when he picked an aggregate from here, because the contractor has not changed, all things being equal, when he picked an aggregate from here, this section, there's rotten. This section, there's cracking, but this section is performing very well. I say in 10 years' time, then we can go and pick samples again and say, then the aggregates from here, there may be a problem. And it just starts from you. And that is when you can now go to the top levels and tell them that this is our data. Sometimes for me as professionals, we speak to politicians, and sometimes we speak like them. I'm sorry. No. We speak like them because when you go to the politicians without data, without scientific information, they will ask you who voted for you. You don't, no. And they are right to ask you because they think you are talking from your mind. But they have the support of the people. But when, and I always use the example of COVID, when COVID came. I'm answering your question. When COVID came, if we had left it to politics, and I'm using Ghana as an example, a lot of people would have died. Why? Because now the medical people were using data to tell the politician that let's vaccinate this group of people. It started here, let's quarantine this. They were using data. I'm sure that's the same thing that happened over here. But if it was politics, every senator would say, no, vaccinate my people. Vaccinate those who voted for me. Not only even my people. These people, you don't vote for us. Or am I wrong? Yeah. That's what but the moment we start using data and tell you that, hey, this asphalt from this particular company that they bring, anytime we use it, there's something wrong. And you have 5 years data, 3 years data to talk to them. Whether they like it or not, they will listen to us. And so, I'm in Ghana Institution of, I tell a lot of our engineers, let our institution, if the other institutions are not doing it, let's build a data repository. The moment we build a data repository, we will be able to change our country. The difference between us, and I'm repeating what I said, and let me say the developed nation is they develop systems based on appropriate data collection. That's my, I don't know whether I've answered you, but I tried. I think the earlier question, I think your premise is right. You talked about the gyration. And yes, so maybe I didn't emphasize this, but if you looked at the left, there were, and once again, I've not emphasized it throughout the presentation, we have the traffic levels. So based on the traffic levels, there are numbers precisely. So you see on one of the tables on the left-hand side, you see the number of the easels ranges in million easels, and that's what you use to determine all those things. Thank you for that, and thank you for bringing that because at least it's something I left out. Thank you. Yeah.
Thank you, Doc. My question is on the super pave mix design. It is called super pave because it offers superior, performance. I want to ask about certain factors that we need to integrate, when we are doing design for super pave. I live in state. I work in Kaduna State, and then it's a state with high, rainfall, especially in the southern part. And then traffic is also extremely high in my state because it's a gateway state, to most other states in the Northwest. And so how do we integrate, environmental considerations, especially moisture, and then traffic when we are doing design for this super pave? That's my question.
Thank you. Maybe any other, then I'll come to that.
Any other? Okay.
All right. His one will be 3, so let me answer this. All right, so yeah, you are right. So I think, the 7th point that I showed was on checking moisture susceptibility. So that is to take care of rainfall, whether there's going to be moisture damage, and these are standard tests for whether there's going to be moisture damage or no moisture damage to your asphalt. But beyond that, he rightly drew my attention that I didn't emphasize traffic. So like you talked about, traffic is very key. But beyond that, the combination of moisture, air, temperature, and everything leads to oxidation of your asphalt. And that's what of your binder. That is what we simulate in determining the binder properties. I hope you understand. And then understanding that having a moisture or a binder that can last long term under the PAV, and also having a mixture property in the long term will help you in dealing with that. But I said super pave is not the panacea. You need to start also dealing with the balance mix design within your state, looking at, okay, what are the problems? So you see, in these things that we started, I said they collected a lot of data. They collected data on actual pavement performance, okay? And looked at the mix and the correlation between that. So that's something you can start with. And is anyone into rural roads? Yes. Okay. Yeah, so I'm a rural roads person. So I want to identify with my people. But it's the same way you've heard about the DCP-DN design method. I'm one of the proponents of the, you said?
DCP. No, if you are going to rely on the DCP method for your pavement thickness, we may have a problem.
No. I'm talking about low volume roads.
Yeah, for low volume roads.
Yes. So I said DCP-DN.
Okay.
DN design method. So what we've found out is that, you see, we use DCP, and we always correlate DCP to CBR and use it, and it's generally, the correlation is very low. Okay, so the correlation between DCP and CBR, or catalog it. So what we've developed is actually using DCP as a design method without correlation to CBR. And so under the AFCAP, the recap thing that I was talking about, we did a lot of research. So Tanzania, South Africa, Ghana, Malawi, most of them were in the Southern and East African, Uganda, and UNRWA. We collected a lot of data, Kenya, and you can read the literature on the DCP-DN. But the reason I brought that is also, once again, we looked at performance, and how it correlates with what? Design, basically actual performance. So you can read about DCP-DN, not just the DCP, DCP-DN design method. DCP-DN or stroke DN design method. Yeah, you can go ahead.
Thank you very much, sir. Thank God we are from the same constituents of low volume roads. And so some couple of years now, the ramp has been trying to develop a low volume roads, though we have a manual. So that was why I quickly said that the DCP would actually not suffice in Nigeria, because we can categorize our regions into 3. There are places you have that it can work, which is actually one thing. For, I don't know how it happened, we've adopted empirical approach to our designs. The Federal Ministry of Works are here. They can actually, I think maybe we'll get to a situation or a section that we can really address our problem and not just attending conferences and talking and it's there. Now, my question is this. You're talking about the super paved asphalt, and I've been trying to see how it can relate to low volume roads.
Personally, I'll not recommend. I'll not recommend. That's personally. Yeah, for low volume roads, no. It's not, one of the things I teach is economics. We're talking about HDM I just finished some RED analysis, road economic decision model analysis, RED analysis. For low volume roads, it will not be economical. Asphalt itself, will not be.
I'm driving somewhere.
Yeah,
in this part of the world, what attracts traffic is the pavement. So, in a situation whereby you are opening a road, trust me, we have shorter routes, but the federal road seems to be the longest. So when you're on a low volume road, you've designed as a low volume, I can guarantee you that in 2 years, your growth rate that you calculated as 4% might be nearing 8%.
So the problem is not pavement. The problem is understanding of our traffic and having a network approach to planning. And sometimes in Africa, that's our biggest problem. First, understanding, we don't develop networks. We develop roads. I don't know whether I'm making a point. We don't develop networks. We develop what? Roads. So, Ogan will come, let's do this road. And sometimes we are focused on doing this road, forgetting what do we want to achieve. So it's the strategic planning, the transportation planning aspect of it, saying that we want to develop this corridor to send timber to this place. And what are we doing? So what you are saying is right. Because Oga is we call it MP, but the congressman for this area, he says, let's do this road, asphalt. Then this road that links this area to this and come here is still chip seal. That's the problem we have. I don't know whether it's in Ghana or everywhere. That's an Africa. So that is where what you are talking about. So your diverted traffic, and your diverted traffic then becomes so high and unpredictable, and that's a challenge. But you can go ahead. I just wanted to tell you the actual problem. Otherwise, the moment we do that, we are saying that everything that we went to school to learn doesn't make this thing, which is about first of all planning, doing your traffic analysis, being able to predict your traffic, induce traffic, generated traffic, all those things. If you're able to do it, there can be variation, but I can bet you with proper transportation planning, you'll not divert so much. Okay, so, but.
Okay.
Yeah.
Thank you very much. On the back still on the super pave, I'm a bit interested in it, and I'm not sure it's been carried out in the country. I don't know. But I think a bit of research should be carried out on our part, and let's see how viable it can be. So that I said the next, my main question would have been where we have a communique so that we can have the input of the Federal Ministry of Works representative here, and let's see if truly this thing can be achievable in our part. Thank you.
All right, thank you. I'm sure the organizers, we will take this up and help how strategically we do it. And sometimes it's also the engagement. For example, your bitumen suppliers, maybe Shell, is Shell here? Your major bitumen suppliers, yes, you need to start engaging them and whether they can even produce bitumen to the PG grade systems. These are things in the interim you can start. And then once again, it's funding into research. What is their incentive in doing it for you? Okay, so maybe you, if your organization can fund 1 or 2 students to do some local research, and I believe that is the way, but we need to be intentional. And Federal Highway Administration here, that's the name here, Federal Ministry of Works, it's about engagement. With the work we do, I always say that what I call institutional politics, it's about engagement also from us with the politician, letting them know the needs of our professionals and how we effectively engage the federal the ministers and all those things. Just last week, we had a discussion with our Ministry of Roads and Highway, with our Deputy Minister on a lot of issues, but it's for us as professionals, we need to find a way of engaging them effectively to bring the change, because we are all not happy with the state of things, but we can decide to blame the politicians, we can decide to blame but we can also be the change that we want to see. On that note, thank you. I think I'm down for my, hey, there's a question.
Yeah, no, not quite a question, just information. On the last person who asked question in respect of Super Pep. I want to say that we in an institution of highway and transportation engineers were in collaboration with NIBRI, Nigerian Building and Roads Research Institute. Presently, all this equipment you saw, we have them in their labs. They have even brought other equipment that will enable us to carry out some pilot Super Pep asphalt construction in Nigeria. But you know, the politicians, we've been trying to sell these ideas. Let's have at least one political zone. Because all we are doing now is the Marshall test for all our asphalt all over the country. And it's part of this new specification that want to be adopted. But we want to carry out this construction physically for them to see, so that we can now incorporate Super Pep in our own specification, in addition to the Marshall that has been there for the past 40, 50 years. So what you are asking, even now if you go to NIBRI, all these equipments are there, you see them. We've went to a lot of courses, and we have a lot of equipment that will be able to do practical Super Pep asphalt for you in Nigeria. So it's an information I want to give you, that we have them here, they are in NIBRI. Most of these are in our research institute, but we have not practicalized it yet. Thank you very much.
Thank you. Thank you very much. All right, so if there are no further questions, I think tomorrow we will have another section, and I wish you the best. Thank you.
Yes, let's do more for Dr. Patrick. That's a very wonderful one. So please, before we take the next segment, can we just stand up, stretch your body, just, just get up, just stretch it a little, Stretch your body. I'm giving you expo because Dr. Amin has stretched his body before he will stretch you for the next few hours. So do the same. Thank you. You can now have your seat. So we are now back to take the advanced inspection techniques. So once again, we have Dr. Amin Aknok on the podium to take us through this wonderful segment. Thank you.
Good afternoon, everyone. Anybody's tired? Anybody's sleepy? You wanted them to stretch again? Well, if the boss is saying go up, then everybody rise and stretch again. Yeah, let's see. Yeah, I'm waiting. Yeah. Is there a problem adding the PowerPoint? Gentlemen. Okay, no problem. No problem, we still have time. It's not dark out yet. Okay, so welcome back everybody. Thank you guys for posting the PowerPoint. So I'll do my best to get you as fast as possible. Engineer Asa told me to cut my presentation short, so I promise I'm not going to take more than a couple hours. So by probably close to 4 p.m. we'll get lunch. That makes sense? Is that okay, Engineer Asa? You told me don't make it past 4, right? Okay, so again, I'm glad for being here, and my colleague, Dr. Patrick, has presented a wonderful presentation, a lot of insights and a lot of information about SuperPave and development on asphalt mixed design, all the way till the balanced mixed design. He actually raised the bar high for any instructor or guest speakers by the excellent performance he just provided. So now we're gonna proceed with this presentation. I do have a couple two presentations before we conclude the day. This one will be before lunch. It's a little longer than the second one after lunch, which is good because I anticipate after lunch everybody's gonna be tired. So I'll try to go as fast as possible in this and on the one after, so we can get some room for Q&A before we head home. So this presentation's title is Advanced Inspection Technique. And please pay attention here, because inspection techniques collection of data using pavement and bridge management systems or asset management systems are all interconnected. And as Dr. Patrick mentioned, there gotta be a start point. We cannot point fingers at each other. So data collection can start at a micro level and go from bottom up, as well as it could be from a political decision and go top down. So start today, start by yourself in whatever avenue you work in, whether you are in a design firm or working with a design firm or working for the government or working as a consultant or whatever, even if you are a contractor or a lab person, you can still do that. And then having all the size of the data developed and generated today based on the huge network for the infrastructures in Nigeria, in Ghana, in Egypt, in the Gulf, in the United States, that leads to what we call big data. So the analysis is no longer going to be done manually. Somehow machine learning, computer algorithms, and artificial intelligence sooner or later will kick in. Otherwise, if we collect a lot of data and we cannot use it to optimize our decision making, there is no value for the collection of data. So the process is long. It's a long road, but you know, it's never too late, right? So starting with inspection, going through data collection, adopting a pavement or bridge management system or asset management system, and then incorporating machine learning and artificial intelligence. That is the roadmap for success whenever you deal with day-to-day events, especially when big data is incorporated. Now, for today's presentation, I'm going to mention some points about non-destructive testing, because this is a way to go, and this is a new trend. You know, usually doing destructive testing is an easy decision. It gets you accurate results. However, it's very costly, whether you talk about time or money, or it needs a lot of human resources. So what are the advantages and the disadvantages? Then I'll mention a few things about the use of advanced technology. I mean, it is advanced, but now it is like 15, 20 years maybe in the market, like GPRs, ground penetrating radars, or thermal photography, or UAVs, unmanned aerial vehicles, or drones. Even that takes us to robotics. And then finally, the use of LiDARs. Again, please pay attention here, because that is all interconnected, starting of this presentation with the one we will have after the lunch, and then tomorrow once we start talking about AI and machine learning. So now with NDT, why are we using it, or what is the need? Basically, we are trying to avoid using destructive testing as much as we can to avoid expensive or expenditure, while we are, as we saw yesterday, we're having already budget deficit at least of a 50%, and I'm talking about the US. So this is a quality control procedure that doesn't cost money and technically shouldn't take much time to do. You can evaluate tons of things, whether talking about bridges, talking about roadways, asphalt or rigid pavement. You can quantify you know, a strength of a section, any signs of de-stresses, whether you know, raveling or cracking, all types of cracking, rutting. We can quantify voids or pockets within the soil or within a concrete section. You can identify corrosion, location of pre-stress bars or reinforcement bars in a concrete section in a bridge project. Also, you can detect cracks and see where the cracks are and their pattern. Oops. Okay, these are the needs for non-destructive testing. Some slides are self-explanatory. I'm not going to go onto their details. However, just keep in mind that you can basically detect almost everything you can reach to using destructive testing. You can reach it with non-destructive testing. The only thing you need to do is being well trained and having the proper piece of equipment whenever you do the job. Once you have that, then the sky's the limit. You can collect as many data, you can do as many testing at a fraction of the cost compared to having destructive testing being done. So different types of NDT, that includes penetration methods, which is kind of borderline but still considered a non-destructive testing method, rebound hammers, pull-out tests, ultrasonic pulse, radioactive methods, rebar locators, crack monitors. And I'll go a little fast on the first set of them because I assume they're now pretty common everywhere on Earth. You use these type of methodology, right? Like in penetration or resistance method, like Windsor probes. Anyone use it here? It's not? Oh, you use Schmidt-Hammer. Okay, I mean, it's not very far off, but the penetration or the resistance method or using Windsor probe, it's basically dependent on how much the resistance is going to be to penetrating a given surface. Schmidt-Hammer or the rebound hammer, it measures how fast and how big or how strong the rebound is going to be. Both technically would give you the same results. More or less, the penetration resistance method, it is used more into the detection of uniformity. And again, here I'm talking about rigid pavement. I'm talking about reinforced concrete section in a bridge project. As anything, it has got some disadvantages, whether talking about accurate measurement, about very well-trained personnel, and basically you have to watch for anomalies because whether we talk about regular rigid pavement like Portland cement concrete pavement or a concrete section, you might end up having some embedded rebars of the reinforcement or pre-stressed strands or coarse aggregate particle that is very close to the surface. It will end up giving you a very high, unreasonable high result. So technically, or it could be the opposite. You might end up with an air pocket near to the surface and you get a lower number that is lower than usual. So you're either underestimating or overestimating. So in order to get yourself out of this problem, always think about conducting 5, 6, 7 tests for any given section, and then you take averages, or one of the methods, you calculate the average, you add 20% plus or 20% minus, you go back, any result that doesn't fall within the plus and minus 20%, throw it away. The remaining results, do the average for them, and this will be your final value. I'm not sure here, can we play videos? Because technically this is a video here. Is it slow, the connection? Because it should pop the arrow. Maybe. Yeah. Yeah, gentlemen, at the end, I'm going to give you a hard time this presentation. I have a lot of links. So I think they're nah. Can we go back to the previous slide and hit on? Yeah, can you click, please, on this? Looks like when they click, it scrolls to the next. I don't know why. Is the connection slow here? There, what? Okay. I'm taking some pictures now. How big?
All right, so today I'm going to use the Windsor probe tool. There's some more modern versions that have like an electronic piece that you plug into the probes. I'm using an old school one. But anyway, just to kind of show you where we're at, right there on that X, they want that tested. There's the tool, just a little slab. They're starting with the CMU block. Sorry about the noise in the back. But we're gonna test this area here. Try my best to do this on my own. Sorry. So this is kind of what it looks like here. I'm gonna need this gun and this brush, and I'm gonna screw the tip onto the brush here. Screw that on. So I have, it's like cleaning the barrel. Well, I guess we are cleaning the barrel of a gun. So I have the gun here. I'm gonna open it up. So I have the gun. I'm gonna turn it sideways and open it up. I'm gonna get this brush I just put together. There's this little piece here that holds the bullet. We'll look at that more in a minute. I'm gonna clean out this barrel. Clean out the barrel after every 3 uses, or after every 3 shots, which 3 shots actually equals 1 test. So after every location. So I'm done with that.
3 shots equal 1 test.
I'm gonna set this down.
Keep that in mind.
Leave that piece out. And as I take my box apart, here's the triangle plate with the holes in each tip that I'm gonna shoot into. So I'm gonna set that down right there above my location. Next, I'm gonna open up this little bag here. Each bag comes with 3 probes and 3 bullets. That's what the probe looks like. It's got thread on top, and then it's got that little rubber piece along the shafts. Has 3 of those. And then inside this bag is another bag that's got the 3 bullets or 3 charges, or however you want to refer to them. It's just a little bullet. And set those down. So what I'm gonna do is I'm gonna shoot 1 into each corner here. All right. I'm gonna grab this little piece out of the box, and I'm gonna screw this onto the tip of the probe as far as it goes. Obviously, it won't fit in that way. Well, I guess it will, but it doesn't go in that way. So the tip of the probe that goes into the concrete is gonna go into the barrel first. Shove that in there. This metal piece that stays in there that came with it, put it back in, push it in as far as it goes, and then slide the bullet into that piece. Turn it sideways, clock it, it's ready to go. So then what I'm actually gonna do is find one of these corners, put the gun all the way down, right here in the center. I know you can't see it, but there's a little yellow there's a little yellow piece that comes out of, there's 3 holes there, comes out of the center hole. I'm gonna push it all the way down, keep it nice and straight, 2 hands, and pull the trigger. Take this off, it smells like a firework. Open it up, take this piece out. Take the empty bullet casing out, get rid of that, and unscrew the metal piece here. Now that I have 1, if I need to, I can still move it around. But I don't need to, I'm just gonna leave it there. I'm gonna load up my second one. Screw this on here. Screw that on the probe. Slide the probe into the barrel. Put that piece on. second bullet, put it in there, close it, ready to go. Nice perpendicular shot. A little bit of concrete splattered. Always use your safety glasses. Take it apart, piece out. Use an Allen wrench here to knock that casing out. Sometimes it gets a little stuck. Unscrew this piece. Screw it on the next one. And load it up for the third time. Slide the piece in there. Oh, that's my empty one. Put my last one in there. Got it loaded, ready to go. And we are done shooting our 3 shots. Take this out. Remove the casing. Since I'm done, I'm gonna put this back in. Put the gun back together. Set it off to the side. Now I'm gonna remove this template. Oh, gotta remove that piece first. That was screwed onto the top of the probe. Put it back in the box. I'm gonna remove the template. Then I'm gonna remove the plastic pieces that were around the shaft. So all I have left is a shaft that is 3 pieces, is a 3 probes sticking out. Okay, so now here's a little video of the 3 probes, 1, 2, 3. Before I put the plates on, I want to get all that concrete out of there. Make it nice and clean because these plates need to sit flush on the ground. See, I left that little plastic thing on this one to show an up close. Pull that thing off the thread. Take this, throw it away. Now that my floor is clean, I have these two plates. The one with the hole goes on top. So this is gonna fit over the probes, just like that. 1 probe in each corner. Then I have this one with the hole. This one goes on top. These 3 holes here, they're gonna rest on the probe, this plate. So now I have this this gap here. Basically what I'm doing is I'm measuring that. All right, so I had to put the camera down because I need 2 hands for this next step. But I got this tool, and basically what it is, this thing has a spring, it goes in and out. And right there, it has the depth that it measures. And I'll show you a better angle of this in a minute. But basically what you're gonna do is there's a hole right here in the center of this plate, and you're gonna push it down to line up with the arcing underneath. Push it down all the way, and then when there's a set screw on the back that you're gonna tighten. And that is your, then you take your measurement reading. So this is what this looks like. I don't know if you can tell, but down in there, in that hole, there's a little dent in there. So what you're doing is you get your tool. I have the set screw set, so it's not gonna, but you set it through the top hole, and you put the tip in the bottom dent. If you notice, the shaft to this is all the way on the top plate, and this goes up and down, but what I did is you push it all the way down, and then you set your set screw. Now what I'm gonna do is I'm gonna take this out and read it, and I'm reading a 1.7. Just short of 1.7, but it's closest to 1.7. So I'm gonna go with that. And then depending on what charges you use, depending on what standard tables you use, all these kind of things, you look at your chart. Come on, there we go.
Yeah. Now, do you follow up what he
that's right there in
did?
the center, and that's going to tell
He's
me that
basically,
my
you know, the higher the depth, the longer the distance is gonna be. So it's kind of calibrated based, it's all empirical type of research, so it correlates the compressive strengths. The page he was showing was like 3,000, 4,000. These are compressive strengths at 28 days. In America, they go by pounds and square inch. So 4,000 PSI is 28 MPa. Usually 1,000 PSI is 7 MPa. So where he showed like 3,000 plus or between 3 and 4,000, that means the strength is somewhere between 22, 23 and 28 MPAs. So this is one way of doing business through penetration. Now, I'm not sure if I clicked, will it go beyond? The other one is the rebound hammer. I'm probably going to skip the video because I assume a lot of you already knows about it, right? It's in the US it's called the rebound. In Europe, or because of Germany, they call it Schmidt hammer. Basically here it's about 4 pounds or slightly less than 2 kilograms, and it is applied perpendicular to any surface, and it computes the rebound. Now, if you use it vertically up, then the gravity is helping you. Then you have to use a factor less than 1 to get it back to the horizontal value. Now, if you do it down, like you're, let's say, inspecting a rigid pavement or a bridge deck, then the rebound will be reduced by gravity. So you have to consider that you will multiply the number by a factor that is more than 1. These numbers are given to you with the device you purchase. It's always like that. So you have to consider exactly, are you doing a horizontal test for like a wall, or are you doing down for a bridge deck or a roadway, or doing up for a ceiling or a roof, concrete. This is about Schmidt hammer. Now, lots of limitations. You have to do multiple testing because of the impact of any anomalies, any air pockets, any voids, any coarse limestone particles, or any steel rebars right below the surface you are inspecting. The advantage is it's dirt cheap. Like, I'm not sure how much you pay for it here, but I personally just purchased one to my lab. It's less than $1,000, like $700 or $800, and it is very easily used. You can have an undergraduate student working with this. This is how it looks. That's a Gilson company rebound hammer, which again we call it rebound in the US. It's Schmidt hammer in Europe. I don't know why it worked that easy. Then let's see it. It's a 1 or 2 minutes, less than 2 minutes, I guess. So see the 3 lines that are shown. The middle one is if you are doing a horizontal testing, and then the top one, to compensate for a reduced reading, which basically are going down, and the opposite. If you are doing up, then you have to take the lower line. Now, pull-out test for concrete, I'm not sure why it is considered on standards as a non-destructive testing, because I honestly see it as a destructive testing. We do this a lot when you have bulk concrete poured. It can also be done on bridge decks or in rigid pavement. It depends on applying a pull-out force for that embedded device, and the amount of resistance offered while you do the pull-out is an indication of the compressive strength. I'm gonna skip this one. Limitations, it creates minor damage. That's why I'm saying it's borderline. You cannot call it a non-destructive testing 100%. But advantage, it gives you a lot of information even about the maturity. You can use it for relatively fresh concrete that are recently poured. Now, ultrasonic pulse, do you use this for bridge decks per se, or some roadway investigation? Anybody is aware of the ultrasonic pulse, how it is implemented? So what exactly you use it for? Exactly. One major use for this in infrastructure, it is for bridges that are poured on stay-in-place metal forms. You know, right now, the #1 bridge system in the US, probably all over the world, is the use of eye girders, precast, pre-stressed eye girders. So once you place the girders on top of the piers and the abutment, in America, they have a problem with labor. I mean, in our part of the world, labor are not the problem. It's probably the material cost. So in the US, they use corrugated metal sheet. They place it on top of the girders, then they pour the decks, and they don't care about removing or retrieving the forms. They leave it. That's why they call it stay-in-place metal forms. So it stays during the lifespan of the bridge. Now, this has an advantage. It cuts down the cost, right? It might act as a protection for the bottom fibers. However, it also ends up as something that deceives the inspectors, because once you go for a bridge inspection down the road 10, 15, 20 years, you don't see the bridge from below. So sometimes there is a huge deterioration or concrete spalling or corrosion of steel, and the inspector cannot see it. 30, 40 years ago, they used to do the kind of Wild West, as I call it, inspection. They used to send the DOT, Department of Transportation inspector. He stands below the bridge, he pulls a pistol and shoots a bullet, a real bullet, and they see how much it penetrates, right? Right now, by ultrasonic pulse, they can basically tell if the concrete section is still there, or you have excessive cracking, or spalling has happened, or even steel is corroded through the speed of pulse propagation through the section. So you can basically tell what's going on even without seeing because of the cast or the stay-in-place metal forms. This is another shape for the device, and this is handheld. I do have one of these in my drawer. You can basically measure the speed of propagation through anything, including a short beam, and that could tell you the quality by, correlating the speed of flow, how fast it goes, versus, the speed is an indicative if you have voids or air pockets or cracks, or if the concrete is very dense, which means it can be correlated to the compressive strength through this non-destructive test method. Application-wise, it can be used in different infrastructure application, mainly bridges or bridge decks, or concrete surfaces like rigid pavement. There is nothing wrong about using it in asphalt. However, it's not preferably used in asphalt because I'm going to show more advanced technologies that are being used when it comes to non-destructive testing of roadways in a couple minutes. Yeah, this is one of them. The ground penetrating radar. Anybody used it here, or GPRs? Anyone used GPRs? Ground penetrating radars? Or what about the idea for ground penetrating radar? So basically, this one is a sound or a radar wave, actually. It is emitted by a device. It could be a handheld device. It could be on top of a drone. It could be pulled by a dolly, or it could be attached to a truck. It depends how big the size of this device is. Through the penetration of radar waves, and it could go up to a couple hundred meters. So it can tell you what's going on under any surface. So this one is used extensively on top of any asphalt. It can tell you the thickness of the layers. It can tell you the quality of the layers, the possible presence of deformation. It can be used even for utilities if you are trying to investigate the presence of utility pipelines, electrical cable before doing excavation, so you don't hit anything. The GPRs can easily tell you this. Now, when you use the GPR, this is how one of the devices, the handheld. We do have a couple of these. This is more or less about $30,000 US. You can find cheaper ones for like $5,000, $6,000. You can have expensive ones more than $100,000, $150,000. Depends on the size, depends on the frequency. Bear in mind, the higher the frequency, the better the resolution. However, you cannot use higher frequency for depth, big depth. So if you are talking about a couple meter below the ground, like for pavement application, you can use as high frequency as you want. But if you are talking about piles, like drilling piles or so, depends on how deep the pile would go, 15, 20, 25 meter. The deeper you go, the lower the frequency that should be used, right? But it comes at a cost where the accuracy go down. Now, this one here that shows us the outcome of a ground penetrating radar. It looks like a sonogram or a cardiograph. You need a medical doctor to read your cardiograph per se. This one you get like a 1-week training in the company that produced the GPRs, and it can tell you how to correlate or how to read this. So you can spot if you have denser material or a thicker layer, like if you have soil layers, the thickness of every layer, what is the primary composition of every layer. If this one is for a bridge deck investigation, so you can see they are making where rebars are, so you can detect the thickness of the cover. You can tell basically if there is a significant change on the size of the rebar, maybe it's an indication of corrosion. They use it also for pre-stressed girders to detect if some of the pre-stressing cables are cut, like mismanufacturing, or during the pre-tensioning. Sometimes, once you pour the concrete and you release the strand, it gets destroyed in the middle, so you lose the pre-stressing. This could be one way of doing business. You can use the same, like in the US, a lot of the time we were investigating some corridors for the Department of Transportation to find most suitable way for going through like woods or jungles, and we find graveyards. The old history of the US, there were Red Indians or the Native Americans. They used to live on settlements or isolated locations, and then after a lot of them, they die or a disease happened, they bury the people and they walk away. And then disconnection happened in the history. Nobody remember what was going on in this place. So a couple times I was out with the radar, this one I showed, and then we spotted dead bodies buried under the ground. It's a little scary, I know, but it is what it is. So this is the GPR, and this one, it's good that it can tell you what's going on under the surface. So you can inspect inside a concrete section, under the pavement, or within the base or the sub-base, or even on the soils or the soil layers, or the existence of caves. So it is penetrating. Why am I saying this? We will see once we come to LiDARs, which is extensively used for asphalt. Most of the asphalt problems are superficial. You can detect, you don't need to go in penetration unless you are checking for bottom-up rotting per se. Bottom-up rotting, you'd use a GPR, but if anything top-down or transverse cracks or alligator cracks or potholes or raveling or you don't need to go deeper. So basically, investigating the surface will be more than enough. And for this, we don't use GPRs. You don't need penetration. We use LiDARs, which is light-based, not sound-based waves. So here, you can see, these are utility pipes buried. So if you are doing excavation, you don't get to hit the pipe, assuming that you don't know their location, you don't have, maps for this. So that could be a very good way to do the business without hurting the utility or anything that is buried under the ground. Now, thermal photography. Anyone is using thermal photography or have implemented this? It is basically having a heat map developed by a camera. It's a camera that doesn't literally take pictures, but it gives you some sort of mapping for the temperature around the place if you take any random photo. So basically the manufacturers, the way they advertise it, they can go to a wall like this, take a picture, it will show just, let's say, something like a blue layer, because the temperature presumably is going to be, unified for this board. Then after this, the person who's selling the machine, he puts his hand like this for a few seconds. Then guess what's going to happen? His body temperature is going to be reflected on the wall. So if you take a picture, it will show his hands as a change in the temperature. And it tells you roughly what is this temperature being spotted. So can you tell me what can we use this for in our business, in infrastructure work, or in construction in general? Any idea? Try to be innovative. I know everybody is sleeping, everybody's tired, so what can you do with the thermal photography? Huh? What about the asphalt? That could be one thing. Now, I mean, it could be, but I haven't seen this being done. Like one of the things, if you do a rigid pavement or you are pouring a bridge deck, remember you are pouring tons of concrete. What are we doing right now to test the quality of this concrete? Basically, you take cylinders or cubes and do destructive testing, right? So you have to wait for some time. I mean, technically it should be 28 days. However, after day 1, 3, you can kind of guess how the line is going to go, right? But again, it could be too late. By the time you know concrete has hardened, maybe the contractor has pulled out the forms and he walked away. So think about using thermal photography. Once concrete hardened, what is the major properties that can tell you that the concrete is in good quality during fresh concrete mixing? Is the hydration of cement exothermic or endothermic? It's exothermic, right? So once you add water and cement, once the hydration starts, temperature goes out. So based on the amount of cement, the amount of water, the water-cement ratio, which basically controls your strength, you'd have equivalent heat being evolved. So one of the uses that was one of the research projects I did, and they are implementing this on North Carolina Department of Transportation, where I do research through my university. They attach the thermal cameras to drones. And when a contractor is pouring a bridge deck, they fly the drone, and the drone is capturing through the camera how the heat is going on. So if they spotted much higher heat, it means something is wrong there. Could be false or flash setting. The concrete is hardening like it's a fake manner. This is not a correct hardening. Or if an area is much colder, that means you probably don't have hydrated cement or the amount of cement is not correct. So you can literally spot where a problem could exist. Now, people doing business on HVAC, you can use this to spot any leakage if the insulation is not working well, because temperature will not be as what you expect. So people for mechanical, they can do inspection for engines, right? You can do for pavement, when you lay pavement, you can detect what temperature is the pavement being laid at. So there is a lot of remote testing on a massive scale for quality of materials using thermal photography. Now, this is how things could look. You see the temperature? That is for asphalts. You can somehow, if you have potholes, could be detected because of the tendency to retain moisture. So temperature could be different. Now, using drones, this is one of the technologies. Can you guys at the back help me play this video?
Argus died.
Now, the example here is for bridges, but it is being used for everything, basically. It can be used for pavement, flexible, rigid. It's used, honestly, more on bridges, specifically with signature bridges like cable stayed or suspension or suspended bridges, because of, it's very hard to be visualized. You cannot see the connections, the pins, the cables. So always, instead of blocking traffic and trying to have like somebody climbing and doing risky activities to do one inspection, flying a drone like this can generate tons of data points for you in a very safe manner and without any problems or without any blocking for traffic. Now, think about the amount of data points you are collecting when you use drones or when you use these types of testing, or LiDARs, as we will see. You have hundreds of thousands of data points for an extensive network of pavement or bridges. So this has to be the start of the implementation of artificial intelligence, because basically you cannot analyze all this data or generate trends or make decisions, optimize decisions for replacement or maintenance without accurate analysis for the big data, which can never be done using manual effort. Yeah, now the LiDARs. Who is familiar with this technology? This is literally the new kid on the block. And for anybody working in asphalt, you really have to adopt this technology. And that has to be the start of any pavement management system or the implementation of any asset management system or the implementation of AI and machine learning. Why is LiDAR? First, the word LiDAR, it's light detection and ranging. LiDAR has a disadvantage: it cannot penetrate. It always deals with the surface. Remember, light speed is the fastest speed on Earth, right? Anyone knows how fast the light goes? Any guess? 3 times 10 power 8 meter per second, right? Yes. So in kilometer per second, it's 300,000 kilometer per second, or 3 times 10 power 5. So when you said by 8, that is in meter per second. So think about this. You have a small device, could be as your hand like this, or it could be bigger device. You know, anybody heard about Waymo, which is the next Uber? It is being used in some states in the United States. It's basically an application called Waymo. If anybody attended the IRF conference in Arizona, who's saying yes? I can't see. Yeah, you were there and you saw Waymo? Yeah, basically it's an app like Uber. You call it, the car comes, you open the door, there is no driver there. It's an autonomous vehicle, it's self-driven car. And you put where it should go, and it takes you. So it's basically automated Uber. How is this working? How would the car manage to dodge other traffic, other cars, a car stopping in front of it, a human being is passing, a car door, they actually show you this. If the self-driving car is going like this and then somebody opens a door or throws something, an object, it applies the brakes. in a split, in a very small fraction of 1 second, it takes the decision. That's first AI, and it has, to make this quick measurement through this LiDAR. Because of the light speed, how fast it goes, you are in 1 second emitting thousands of rays. And the way the rays are reflected is being interpreted, right? So you can use this for self-driving vehicles as in Waymo. You can always go to YouTube and write Waymo, W-A-Y, that's way, and then M-O, Waymo. This Waymo would show you, it's a car with a LiDAR, circular LiDAR on top of the car. And it's going continuously like this. And based on what it captures, it tells the car where to go. Now, how do we use this in our business? Basically, there is all or every state Department of Transportation, and I'm sure it will happen in Nigeria, if it didn't happen already by now. There is smaller trucks, it's called ARAN, A-R-A-N. You have it here in Nigeria? You have one? Okay, so these are working by LiDARs, by the way. All the ARANs are working by LiDARs. It's automated road analyzers. It has LiDAR system and a GPS attached to it. And how fast it goes here? 60 kilometer per hour, 50 kilometer per hour? Yeah. So basically, through this IRAN or ARAN car, you can inspect, think about it, 60 kilometer per hour. So in a working day, 8 hours, you can inspect 500 kilometer of a highway, or more than 300 miles. Through the LiDAR, it's capturing. It can basically tell you, and through the GPS, it tells you the location. And the LiDAR is telling you what kind of an effect you are seeing through the reflections. What it does is it emits the ray, the light ray, it measures the reflection. And it is programmed. Some LiDARs, they are not emitted by cars. You can do that from a boat if you are trying to get like the depth of the ocean or the bed of the ocean or the bed of the sea. Like when, God forbid, a plane crash and it falls in the ocean. How would they spot the location? They have, LiDARs. Is it time?
No, lunch is ready. So maybe we can, according to time.
No, I'm finishing. Yeah.
We'll go come back.
Yeah. Okay. I'm being kicked out. That's a message. So they have LiDARs on boats. So LiDARs could be on ARANs, the trucks. It could be on boats. It could be on aeroplanes, aero or flying LiDARs. They emit the rays. They capture the reflection. Now, think how fast it takes the decision. If you emit the ray, let's say this is your car, or this is your airplane, and you're horizontally flying, then it will go vertical down, vertical up, right? But is this the case? You're having wind. So you have three possible deformations. We live in a 3D space. So it could go like this, or like this. Or it could go like this, or like this. Or it could go like this, or like this. You have triaxial, so any inclination around any of the axis would result in an inclined ray, right? It takes that into consideration by measuring the angle of your twist. And it's automatically factored in on capturing the surface or the level where it comes back off. Like here, it can spot jungles or trees. Topography. They spot if there is erosion for shorelines. When the shoreline recedes, it can tell, year after year, by flying the drones and capturing where your shoreline is and how fast it is receding. So when it emits through the ARAN and it hits into a pothole, what do you think? The speed of light, it will take longer distance because the pothole is deep than the regular surface. So it can tell you there is a pothole. Now somebody might say, okay, but a crack would do the same if you have a longitudinal crack. That's where the AI comes in, because you teach your machine that this pattern of capturing the drop on the asphalt is equivalent to a pothole. The other pattern could be a rut. A third pattern could be a crack. It's like the image recognition. When you go into a bank or so and they put your picture into image recognition, that's AI, because when they will think about a lady, one day she could putting or wearing a lot of makeup, other day long hair, other day short hair covering her hair. Still it will recognize the lady. That is because you teach the machine this kind of image recognition. Same way, any truck or any ARAN is equipped with this. You have the LiDAR, it tells you what kind of data, what kind of depths you are measuring. A GPR, it tells you the exact location. AI, where it can tell or translate this rigid data into a crack or a raveling or a pothole or rut, etc. So by the end of the day, you can have a scan for a 500-600 kilometer worth of a road network only done by one person driving one car at almost the same regular speed of other traffic. So you're not impeding traffic. It's 100% accurate. It is the start point of data collection. However, if you do not have calibers to collect and interpret this data or use the AI to interpret this data, there is no point of capturing this type of data. Any questions so far? Uh-huh. Okay. Yes, that is a After
that, do we need any other method of measuring level to confirm the accuracy of the LiDAR? That's number one.
Well, you can, and you definitely, that's one of the main uses, is the topography. Like if you are trying to detect a corridor where you put a roadway without doing extensive excavation and backfilling, like a balanced excavation, right? So this is definitely one of the major use of LiDARs. That's the first part of the question. The second part?
If we do it, we can conclusively calculate our airport.
Definitely, definitely.
Then you have just said that it's not very good in creating Earth.
Yes.
What of water bodies? What of water bodies? Can it be used for bathymetric survey?
Yeah, that's a very good question. It is shown on the video, that's the last slide. There is specific LiDAR where, I mean, remember, it's a light wave, right? Yeah. It can penetrate through water. I mean, the quality is going to be a little different than when you do it through air. But still it can penetrate through water. What I meant was you cannot measure inside, like you cannot per se do geotechnical investigation and tell what type of earth layers do you have, as in the GPR. You cannot put the LiDAR on a concrete surface or a concrete pavement and tell where the rebars are. This is a GPR job, not a LiDAR job. But the LiDAR can penetrate through water and do inspection, let's say for a crashed airplane that is drowned or any shipwreck down there. It can be captured.
Okay, finally, what is the limit of height at which it can collect ground levels? Because, I don't know, like as in advanced photography, it can have a higher height.
Yes. I mean,
for LiDAR,
yes.
Can you also achieve a great height, or is it?
There are satellite ones. Now, how accurate they are, honestly, I'm not sure, because the ones I use in my research, basically I do like a 50, 60 meters high. But no, I mean, it can go much, much higher than this. But how accurate would it be? I honestly cannot tell, because I didn't do business on that satellite level type of. I mean, let us play the video before continuing, because the video might answer some of the questions. So can we do that? Can we play the video and then I'll answer your question. Can we play the video, guys, at the end?
Transportation and infrastructure are the veins that keep an economy's blood flowing. Maintaining and monitoring these vital roads have long been a labour-intensive task, requiring many man-hours and a multitude of skills on-site and off-site. Site visits and manual inspections up close were the old standard for infrastructure monitoring and surveying. With the number of road users increasing daily, highway concessionaires, local councils and state-level road transport departments play a pivotal role in ensuring that the roads are safe and conducive to smooth and efficient traffic flow. With Acre Solutions' mobile mapping system, capturing road conditions and digitizing the results are now faster, easier and more cost-efficient. The smart 360-degree camera and LiDAR assist road operators to acquire high-quality data and images which are useful for effective analyses. Acre's mobile mapping system is deployable almost anywhere and can be fitted to drones as well.
So they can install it on a drone as
Two
you see
types
or
of
on a
LiDAR
car.
can be used for this purpose, ground and aerial LiDAR. Aerial LiDAR complements the results obtained from ground LiDAR by including data that is otherwise inaccessible by road. Using both LiDARs concurrently enhances the accuracy and precision of the mobile mapping project as it allows broader access to clearer data. This is essential to establish the repair or maintenance work required on each asset based on needs, severity and priority. Georeferencing is key to job efficiency and plays a vital role in cost management. Acre Solutions utilizes the latest technology in mobile mapping, using computer vision, artificial intelligence and automated notifications to identify and alert the system of any road asset defects. Previously carried out manually, the mapping of these obstructions and defects can now be done remotely through the use of our advanced digitization software. Today, Acre is changing the game of mobile mapping. It now takes less than half the time and manpower to complete. Trust Acre to conduct proper assessment of your road assets for a more efficient road planning and maintenance. Acre Solutions brings you the tools you need to solve tomorrow's problems today.
I'm Shamim, surveying engineer for Acre Solutions, and this is our visual-based mobile mapping system.
So now back to your question.
Transportation and infrastructure are the veins that keep an economy's blood flowing. Maintaining and monitoring these...
Okay.
On the use of drone in collecting data on the bridges, is it only the part of superstructure and of the bridge that can determine to collect data? Can you equally use it to collect data underwater?
Drones underwater? Well, you mean like if you attach the LiDAR to a robot or floating robot? It can. Yeah. Well, the LiDAR can penetrate through water, but it cannot penetrate through soil. Keep that in mind. So if you are talking about a pile like driven in soils, nah, I mean you cannot. GPR can. Like let's say, you know, if you are doing the pile driving, right? So if there is discontinuity happening, like let's say you are having a cast in situ pile, sometimes, you know, cave-ins happen if you're not protecting the soil, and then you have part of the pile, then soil, and then the other part of the pile. A GPR can tell you that this discontinuity happened, so you can save yourself from such a problem, but a LiDAR cannot do this. Does this answer your question? Any other questions? Yeah, one more here.
Okay. Good afternoon once again, senior colleagues and my colleagues. My name is Engineer Julie, and I work with Nigerian Building and Road Research Institute. And thank you, sir, for once again selling NIBRI. Actually, we have, while he spoke on the Super Pave, we have all the equipment, we have the PAV, the rolling thin film oven, we have the gyratory compactor, we have all of it. So we welcome you to come and see, and if you decide to start, we actually also have a committee, because we do research, that are working on this super pave mixed design for Nigerian, for the Nigerian sector, for Nigeria, permit me to say. So we're working on that. The DG has effortlessly done that. We have equipped the laboratory. So we welcome you to come to Nibri. We'll take you around, you see, so maybe we can work on this together and make Nigeria great. Thank you very much. Once again, I want to ask, does rebound hammer gives you the compressive strength directly, or it gives you the surface hardness? Is it okay to just work with rebound hammer, or you correlate it with the ultrasonic pulse velocity, and then at least you get the idea to know if actually the strength is okay or not? So I want clarity on that.
This is a very good question, and there is a lot of debate around this point. Theoretically speaking, it can tell you the compressive strengths, or it could correlate the rebound it gives with the compressive strengths of the surface. We can use it even with cylinders. Like some of the research we do, you get, well, cylinders because we don't use cubes. So what we do, we put the cylinder in the compression machine just to contain it, to capture it, do not apply real force, and then hit and see what kind of rebound at what kind of compressive strengths. Then we do the actual destructive testing and we see how it correlates. They can pretty well correlate if the concrete is homogeneous or uniform. What I was saying, which can deceive you or deceive anybody, if the surface is hard at some spots, whether you don't have homogeneous mix, if you're having steel fibers and a lot of it was toward the surface, if you have very coarse aggregate and you did like the hit on top of the aggregate, or if you are doing, let's say, a column inspection and you hit very close to a stirrup, right? And your cover is like 1 or 1.5 centimeter, then there is an impact for the stirrup on the measurement. So at this point, it's always advisable to take multiple measures and do the averaging. Will the result be 100% accurate? I cannot say so, but it is getting very close to reality.
Okay, thank you very much, sir.
No problem.
Why I asked this question is we also have non-destructive testing equipment in our laboratory. We have the ultrasonic pulse velocity, rebound hammer. We also have the rubber detector that can tell you if the reinforcements on your column is actually exactly the number. We have it in our laboratory, so you're welcome to also come. Now, sometimes, like you said, if you're inspecting a column, you know, because the rebound hammer gives you the surface hardness. So if you take points on the aggregate or on the surface that is hard. Now, when we use the ultrasonic pulse velocity, probably the concrete is not homogeneous and is not dense. You see that the rays passed. It's telling you that it's poor. However, the rebound hammer is telling you that this trend seems okay. So how do you balance that? Thank you.
I mean, technically, it's not an easy job, but again, if you're referring to how comparable the results would be, I would trust the ultrasonic more. The reason is, as you said, the ultrasonic, let's say you have 2 feet or like 24 inch or let's say 60 centimeters. It propagates through the whole distance. So if there is a defect at a given spot, the others would give you a better averaging. You see what I'm saying? Or a better reading. So your defect is very localized. So the impact is minimized. While the rebound hammer, it's not the case. So again, the best you can do is, like what I teach my students, make a specific like drawing, define an area and then take multiple readings all over the surface and then take average. So you can somehow try to minimize the impact. But to 100% correlate this to that, it's a very difficult job. I mean, it's honestly, I don't see, I mean, it might be doable, but it needs a lot of research, a lot of data points. Do you have any access to such information? That could be a very good research paper. I mean, we can talk, I can give you my contacts, and I can work and try to retrieve some literature for it. It's a very interesting topic. So any other questions? Okay, so Emmanuel, after he kicked me, he decided that I have to continue. So let's put the next presentation. So guys, if you want to fight, because lunch is late, fight with him. It's out of my hand, right? You want to stand up and do a stretch again? Anybody's tired? Okay, so let's go with our, huh? Oh, ready? Okay, so welcome back to our last presentation for the day. And that basically have some repetitive slides from the previous presentation, because again, here we're talking about methods for data collection. So as I mentioned earlier, and as my colleague Dr. Patrick stated, inspection, data collection, asset management systems, use of machine learning and algorithms and artificial intelligence are all interconnected. It's almost impossible to have an AI presentation or course that doesn't talk about big data, or doesn't talk about collection of data, or doesn't talk about data analysis, right? So the previous presentation about inspection has to be one way or the other tied or interconnected with the methods for data collection. And then towards the end, the second half of this presentation, I'm going to talk about how to do interviews, etc. These are very simple. It could be even an easy read for anybody. It doesn't need any specialized education, or doesn't need even engineers, because anybody, even politicians or economists or any business, does require handling sufficient interviews or sufficient methodology for collecting data points. So that is the outlines of the presentation. It is about the data collection, what are the parameters required for a successful endeavor or successful data collection endeavor, and then methods of data collection, observation, which is what we end up doing in our jobs as engineers, whether the observation for our roadway network, our bridge conditions, our tunnels. Then interviews, questionnaires, and schedules. These could be more into those who are doing literature or data collection for research purposes. I'll talk about the advantages and the limitation of those data collection methods. So data collection, I mean, this is a piece of literature. It's a process through which the information required for successful execution of research or industry work is gathered to answer the, the site problem, whether it's a research problem or a job problem. The start point for data collection has to be the identification of the problem or the task that we are well after. So this is one of the things, especially once we hit artificial intelligence or big data, you're capturing hundreds of thousands of data points in one day of work. So if you spend an hour doing a scan and then you end up defining, oh, I did a mistake, or why would I did so and so, then you will end up with a wasted hour which might not look as something big. However, in the world of AI and big data, I mean, think about you captured few 100,000 or several 10,000 data points by error. So you have to kind of dump them. You wasted an effort for a collection of several thousands of data points. So this is big. So the definition of the problem or the task you are after, whether you are talking about industry or research, is a key point for the success of our data collection. Now, remember about those questions. What data should we collect? Again, think about we're living in a world with automation and AI. So sometimes the guy operating the drone, he's not the engineer. You just give him a task. Those who are operating the ARAN, they may not be engineers. They are either data analysts or well-trained technicians. So you have to be very well in coordination with them, telling them what kind of data they need to collect, how to collect it. You have to pick the right team for the data collection, the right equipment. As I stated, we're having lots of technologies like thermal photography. We just talked about it on the last presentation. LiDARs, we talked about them on the last presentation. GPRs, so if you are doing topographical or underwater, LiDARs could be sufficient. If you are doing something under the earth or within a poured section of hardened concrete or a section of a highway embankment, then you need GPRs, right? And then you have to know what type, what size, and what frequency of the device you are working with to be able to capture with correct accuracy. So it's not just the selection of the equipment or the methodology, it's the specifics of the device you are working with. Now, when to start, and this is also another important question, like one thing I learned when I started doing business with LiDARs carried on drones, you better pick a clear day. You better pick a day with least amount of wind, because that end up with, more accurate measures. Think about talking about light speed, 300,000 kilometer, right, per second. So any deflections or any misalignment in your devices, of course AI, you can correct, self-correct, but why would I do the error and try to correct it to begin with, right? And when should you finish the data collection process and how far back you need to go with your data? And this last question is very important when you try to develop machine learning algorithms. How far you need to go in your data collection. We will talk when it comes tomorrow for machine learning, what kind of algorithms are we using and what type of mathematical operation the computer would use to help us develop some trends, whether we are talking about deterioration models for a bridge or for asphalt pavement or for concrete pavement, or developing a trend for preservation, proactive maintenance, or reactive maintenance. So in order to develop the trend, you need to have to go back in the history and collect data from previous month or probably years. That history has to be defined based on the accuracy of the job and based on the available data and the type of the mission you are going through. So in data, always keep in mind you have original data in nature, which is collected for the first time, or secondary, which is data that is captured from trends. Like those data you can develop using algorithm are usually counted under secondary data because you use data that is captured firsthand to develop an algorithm that gives you an estimated value for something you want to measure. We will talk about this in more details tomorrow under artificial intelligence and and machine learning algorithms. So collection methodologies. I mean, the top one is the most important for us. You know, being engineers, that's what we use in our careers, observation. Any inspection process depends on observation. Whether this observation is done by manual, inspectors are doing this visually, that's the old school, which is kind of being off shape right now because of the expansion on the infrastructure inventory that we have. Like if I talk here about Nigeria and I ask you how many bridges you have now, several thousands. How many bridges you had 30 years ago, maybe several hundreds. What about the inventory of your asphalt? How many kilometers? You tell me a number. If I asked you, go back 15, 20 years in history, it was much, much, much smaller, a fraction of this number. So manual observation could have been an option 25 years ago. Some people are doing it now, but it's not efficient. I mean, it's not going to say no. You can still work manually. But it will take you a couple weeks to do a job that could be done in half an hour using equipment or drones or LiDARs and AI, right? So work smart and not hard. That is when you start implementing the equipment and the machinery in observation, coupled with AI, because using LiDARs and drones with no AI, then you're collecting data of no use for you. So it has to be a full circle of implementation. The other ones below, like questionnaires, interviews, schedules, and surveys, it's more for research or maybe for jobs not related to our business because, you know, I mean, we can do basically surveying for contractors or best practices, but this could be for small-scale jobs and not for inspection or for a humongous network of roadways or bridges. So, observation method, again, this is the most important for us. It could be manual inspection, direct inspection, or visual inspection. Again, it's still being used, but keep in mind, even if it's accurate, but it's not efficient because of the pace of data collection. Now, the use of destructive testing, it's very accurate, but it's very, costly. And it needs a lot of equipment to do that, like high-capacity equipment. Use of non-destructive testing, we already talked about a few of them, like pull-out tests, Schmidt hammer, rebound hammer, ultrasounds. Then radar scanning, LiDAR scanning, ultrasound scanning, automated road analyzers, ARANs, or UAVs, unmanned aerial vehicles. These are all, and have a look at this. I'm not sure how familiar are you with these ones available. The left-hand side one, that is a GPR. This is, again, $40K in dollars. So it's basically, you push that. That could be used in investigating the quality of asphalt, the quality of base, quality of sub-base, embedment of utilities, pipelines, electric cables. So a lot of applications. Again, it is penetrating the surface. Have you seen the one on the top right? The one that looks like a dog? It is a dog, by the way, but it's a robotic dog. I mean, my colleague next door, he's a professor that loves robotics, and he have that dog. He sometimes scare me when I'm working late at night, and he kind of operated from his door, gets through my office, and I find a dog right by my foot, and I'm working on my computer, and it kind of start. That's a true story. It happens, and this one is being used big time when we talk about tunnels inspection, because think about confined spaces where it's very dangerous for human beings, or you could have gases. Let's say you are doing drill and blast. There are tons of methodologies for digging tunnels, cut and cover, tunnel boring machines, drill and blast. So with drill and blast, sometimes it's dangerous. There is still a lot of vapor. there could be some methane gas, could result in fires, or if the area is congested, humans cannot go through, or you are afraid of being like stuck down. So they deploy this type with any type of sensors, gas sensors, camera, thermal camera, even LiDAR. You can place a LiDAR on this one. And then the bottom right is the LiDAR. So access equipment is one of the things that needs to be added or used to augment this process. As you can see, some examples for them. Non-destructive testing, we already talked about it. You can check for water leakage, for voids behind tunnel lining, delamination or spalling of concrete, concrete permeability, integrity and conditions of steel rebars, even integrity of asphalt pavement. Yeah, these are picture for ROVs or remotely operated vehicles or robotics. So you can use them if you have low oxygen locations or poisonous gases or unsafe access or dusty conditions. You can attach any type of sensors or data capturing equipment. So these are being deployed a lot of the time. Again, moisture sensors, gas sensors, or any type of, sensors can be attached. GPRs or ground penetrating radars, we talked enough about them. It is electromagnetic pulse, and you measure the reflection, and you have to be very well trained. Like, it took me a while until I learned first how to pick the right GPR system, what frequency for what depth and what accuracy. That's one thing. And then how to interpret the outcome. Are you seeing a void? Are you seeing a rebar? Are you seeing different soil strata? Are you, you have to learn how to read this. It's like, a cardiograph. If you show it to somebody who's not a medical doctor, he will just see lines, but he cannot interpret this. So location or locating utilities in our infrastructure business to not break into a pipe or a cable, that's a GPR job. Again, you can collect data relevant to voids within concrete or under the ground, moisture, rebars, rebar spacing, diameters, pre-stressed cables or tendons, drones. We have talked enough about it. You can locate something on the surface, like structural cracks, asphalt cracks, potholes, concrete spalling, utility leaks, etc. Now, the next few slides, I'm basically talking about how to conduct an effective observation. First, you have to determine your target. As I said, define your purpose, define your task. Whether you're doing research or working for an industry, what is the problem you are trying to solve? Select the correct personnel, collect equipment, do your observation, record the data. Now, recording data is a big job because of the size of the data. You cannot afford to have a problem. And then analysis, that's where the machine learning comes into play. Now, let's say you do have the equipment, but you don't know what to collect. You basically broke this chain. Or you did a lot of good collection, but you don't know how to store them. That's a problem. You collect them, you store them, but you don't know how to analyze them, or you analyze them manually, and they take you a longer time. Then your decision will be basically delayed. Maybe it's too late to do a maintenance, the bridge is collapsing already, or the roadway is being damaged. Now, observations, I'm gonna scroll very fast through this. You have structured, unstructured. Structured, basically, you do have very good definition of the questions and what you are after. Unstructured, that is a general type of interview, and you have to sit with yourself and think of what you have collected. Now, uncontrolled, it happens, by taking spontaneous pictures. Like, let's say you are flying a drone. We have done a lot of uncontrolled observations during the COVID time, where we have to have what we call constructability review meetings. We have to bring the designer potential contractors, material suppliers, construction managers, and they have to see what is the site that we are working with. Let's say we are doing a new roadway. What could be some possible problems that would stop or result into delays? So instead of having a lot of change orders or a lot of site stoppages, we do the constructability review meeting in site with all the project stakeholders, and they talk with each other before we even start the bidding process. So this way we can try to foresee the type of problems to minimize the site stoppage. Now, when COVID came and there was no site visits, or people cannot sit together in a room or in a car, so the only way to bypass this was to do the, like real-time footage for drones, and that was through Zoom meetings, and everybody was sitting at the convenience of his or her office, and we were talking to each other. So this is considered an uncontrolled. The opposite exactly is a controlled observation. I'm listing here advantages of observations. It's always accurate, it's inexpensive, could happen simultaneously, real time, data are always usable. The disadvantages, you have to be very well trained on what you are doing. And the amount of data could vary, so you have to have very good method of recording. Now, interview is not for us. Typically, as engineers, we don't need to do this. Maybe researchers can. It's like the prep of interview schedule, select the subject, conduct the interview, and I'm listing, types of interviews: structured, unstructured, or focused, clinical interview, group interview, qualitative and quantitative interviews. All this are very good materials to read, but honestly, they're not 100% related to our job. I just included them in order to provide a very well inclusive topic. Questionnaires, I use this a lot, but for my research, not for my industry consultation. Has to be very well defined. Honestly, sometimes it works well, but with the new trend and everybody is busy and multitasking, the outcome you get from questionnaires are usually minimized. I'm not sure if you have this problem in Nigeria, but in the US, like I'm working on a safety project for pre-qualification of contractors with our DOT. So we had a statewide questionnaire submitted to all the contractors within a given minimum, maximum threshold of project cash. Like I think we picked $2 million through $25 million projects. And I think we found 1,800 or 1,900. The feedback we got from 120. So it's not even 10%. So this is one big problem of the questionnaire, especially if you use open-ended. That's a big problem because people have no time to write. They want something closed-ended where they can just answer to. Now I'm listing here essentials of good, questionnaires, advantages and disadvantages. Again, these are good topics to read, maybe if you are a researcher, but not if you are doing a business with construction industry or Ministry of Transportation. You'd probably resort all the time to either visual inspection or the use of non-destructive or destructive testing. And traditionally, or nowadays, everything has to be coupled with big data analysis or AI and machine learning. That basically concludes the second presentation. It's much shorter. Not sure we have time for questions? Huh? We have time. Dr. Francis.
Questions, please.
Is it questions for all the day or for a specific part? Like, should we open the floor? Because I think it's the last session.
And you can open
you can, oh yeah. So, Dr. Patrick, you could join me because it will be for
Please, questions. Everything we have learned today, if you have questions, you can ask. So are you raising your hand? I see you stretching. Don't worry, the lunch is a very nice one. I'm sure. You know, when it takes long like this.
Are you trying to bribe everybody because of the delay in the lunch or what?
I'm giving them information, sir.
It's just information.
So let's have your questions, please.
Yeah, for everything that we talked about today. So ask him.
Let's think. There is one question inside your mind you want to ask. The road, the pavement, the drone. Try and connect it. Is it, we have Ghana, we have USA. So is it correlating with what we have here in Nigeria?
That's done.
Okay. I think they understood you very well. The lecture was, okay. See, these questions are coming now. Very good.
Is it for me or for him? For me? I think it's time for lunch.
Good day, Professor. Could you possibly pull up the picture of the LiDAR that you showed on screen, please? That's the question.
Guys, could you please, you're talking about the last presentation?
Yeah, the last presentation. You showed us a picture of the LiDAR instrument. I saw something touching the wall of the... I don't know
that is a GPR, or it could be a rebar detector. This is not a LiDAR.
Oh, that's not the LiDAR. Can I see the LiDAR, please?
So, guys, can you... is this one?
No, not that one. It's like a vehicle. It's like a truck going through a tunnel. Yeah, it goes down to where the dog was.
Guys, can you put the presentation back, please? If you can scroll it from the, yes, this one?
Back a bit.
Back?
One more slide, please, back.
One back?
Back, yes. Back again.
Back?
Back again. Oh, was it in front? It was like a truck with something protruding out of it, touching the concrete wall. Yes, that one. So the one below on the bottom right.
Oh, this is just an access equipment. It's just to allow somebody to be in there, but that could be one thing. Or you can use a GPR attached to this one. I'm here referring to the equipment itself. Whether you have a human being, like sometimes you do this on a bridge, a human being inside, or you can attach a GPR on it, and then you end up scanning the lining of the tunnel, and that can tell you if you have middle cracks or voids, or if you have water leak or something like this.
Okay, so it's for surface analysis. It doesn't actually tell you what goes inside.
No, if it's a GPR, you can tell what's inside. But if it's somebody doing visual inspection, no, then that's basically a surface.
That's the question. Thank you.
Okay, thank you. More questions? You cannot see.
All right.
Thank you so much, sir. During your presentation, you mentioned to us different type of method of data collection, which you mentioned questionnaire, observation, interview, and survey, if I got it right. Now, but you didn't mention to us the method of data analysis.
Tomorrow.
How, You said what?
That is tomorrow. When we talk about data analysis,
Because-
today it's just inspection and data collection. But then data analysis, as I said and as Dr. Patrick mentioned, that's the first step. So we're going step by step. You have to define the problem, you have to do inspection, you have to collect the data, then you analyze the data.
Okay. Then can I ask this question?
Go
If that
ahead.
one is for tomorrow. Now, when you mention observation, where does experimental method of data collection fall into? What I'm saying is this. You say observation. When you look at experiment, when you carry out experiment in the laboratory, is it not observation?
No, it is an observation. Well-
Because I expect it to be part of the method
No,
of, it's not there.
it's not.
Yes, we only have survey, we have questionnaire, interview.
No, I think
There is
under
no
observation,
experimental.
I put destructive testing, non-destructive testing, use of equipment like GPRs. These are all.
Okay.
Yeah.
Thank
yeah,
you,
yeah.
sir.
No. Anything that end up with you developing an understanding, whether you visualize it or you inspect it with destructive testing or non-destructive testing, or use even remote sensing, right? That is observation.
This is the time I enjoy very much. Ladies and gentlemen, your hand is going up. Okay.
All right, go ahead.
All right, let's take the lady.
Okay, good afternoon once again. Not a question though, but in all of this, I think quality control is very, very key for every engineer. Because if you do quality control and keep data, like he said, if you're using aggregates from a particular source, you have to go and check it. The properties of these aggregates, you do the sieve analysis, water absorption, specific gravity, all of the tests, and then you put it down. Now your asphalt too, you have to test it to know what's the penetration grade. Is it okay? So now after constructing the road, you're beginning to have problem you want to check. So we as engineers, I think it's very important if you're doing rigid pavement, flexible, you have to test your cement, your road, your reinforcement, and all of this. If we do all this testing and you have it's easier for you to be able to trace back and say, okay, this is where I think there's a problem. Also, thank you very much.
Okay, thank you.
Yeah.
Sir.
I prefer standing because of my height. I just want to add something. I say in this year's international workshop by NIHTE, I want to suggest that we make changes. There should be an innovation. This time around, we want to bring up a communique. The communique will be based on the implementation of training outcomes. You all bear me witness. We must have been attending several trainings like this, but how many have we implemented? So this year, each of you will submit whatever you think we should do. At the end of it, we'll bring up a communique. There'll be no thematic areas anyway. Just pick up what you have learned and what you want us to do. By this time next year, when we want to organize it, we'll work towards what we have in the communique, so that as we come here, we'll now say this is what we have done. We'll go to Federal Ministry of Works, we'll go to National Assembly, we'll go to FEMA, we'll go to NIBRI, so that they will not just research and keep there in their library. They will research and we practice it. Because when it comes to training, I am not bragging. Both Federal Ministry of Works and FEMA, in my time, I am the most trained overseas. I was going to America for trainings more than I go to my village. I was going to Malaysia, Canada, South Africa. All those things I have not been able to implement. The only thing I have tried to do was the coal asphalt, which I have implemented. And yesterday, somebody said the asphalt recycling. 2018, I wrote memo to National Council on Works. It was accepted for asphalt recycling to be used by MDAs, but still, it's still unpopular. So I organized with the young man you saw yesterday to lead the team, both Federal Ministry of Works, FEMA, and National Assembly to China, so that at the end of it, we'll see ongoing asphalt recycling project in China. So that when they come back to Nigeria, we're able to insert it into the budget and into the BEME so that we start the implementation. That's what I want everybody here to do. Thank you.
Thank you very much, Dr. Iyo.
All right, so we can't start.
We are almost through.
Yes, ladies and gentlemen, can we please put our hands together for Dr. Amin and Dr. Patrick? So I'll just quickly run you through, I'll quickly run you through what we have done today and what we expect to have tomorrow. So what we'll just do is we'll close the training now and then we'll go for lunch. So today we have looked at super pave and balanced mixed design. That was taken by Dr. Patrick. And we went ahead to look at Roadroid presentation on data collection from Thailand. We had Mikhail Kedbeck. And then we continued to advance inspection technique and then advanced data collection analysis and visualization for efficient roadway asset management by Dr. Amin Aknok. Ladies and gentlemen, tomorrow, please, if you cooperate with us, we'll start at 9 a.m. The facilitators were here at 9. We had to take about 20 minutes to wait for some persons to join. Tomorrow, we shall be looking at development of highway materials for enhanced roadway sustainability, intro to MEPDG and its role in enhancement of roads sustainability, asset management systems, that is pavement management systems, introduction to AI for road asset management, then open discussions, questions, and answers. May I now invite to address us before we go for our lunch? But first, for the lunch, you have your meal ticket. And please, because we are not coming back to have another training session, would like you to exercise some patience and take it in batches so we don't rush to the kitchen, to our dining hall and then badge them. You will enjoy yourself. Very, very spectacular lunch waiting for you. May I now invite Engineer Issa Imwabinu, FNSE, to now address us, talk to us, tell us thank you for today, and then we'll meet tomorrow. Thank you.
He said, I should tell you, thank you for today. So thank you for today. I think it has been a great day. I think we have had the good thing. Again, let me appreciate you. Let me thank you very much for allowing us to rejig the program for today as it were. We had to find a way to rejig it to meet up with the situations as are today. We started at about 9:20, if you recall, in the morning. Please, it was just because we realized it was raining. I wanted to be sure that without the inconveniences of the rain, some people are here sufficiently for us to start. Tomorrow it may not rain, and tomorrow we start exactly 9 o'clock. We don't know what weather it will be, but we want to be able to follow that program judiciously. So try as much as you can to be here exactly 9. And I'm sure, relaxed, you will get if all the necessary information we require, and you'll be able to ask all the questions we need to ask. For today, the actual presentation, we have ended up because we had to collapse or join some of them that were supposed to be taken after lunch. So lunch now is the last item 7 that we have for today. And the moment you are through with your lunch, I think you'll be free to leave. As we are going on with the presentation, there is a group a WhatsApp group that has been formed. Please make sure you are in that WhatsApp group. All the soft copies of the presentation that have been made to you will be dumped there. You have a flash in your bag. If you want to recopy them for safekeeping, you can do that on your own. But if you want to retain it there, you can retain it there. That WhatsApp group will remain open for quite some time, almost up to 6 months after the program. But I will advise that you copy whatever information you get there as quickly as possible into the flash that we have provided to you, so that it can always be, you can have a reference point for it anytime in future. Lunch is ready, and we actually want to appeal. Since it is the last time for the day, we don't need to crowd up that place. Maybe we'll go in form of batches to go there and have our lunch. Everything has been prepared, and I'm sure you are going to have a delicious lunch for the end of today's program. I think on this note, we can now maybe raise up and do the necessary closings, and so that when you finish with your lunch, that is it. Thank you so very much for your cooperation. We are halfway done. We have 2 days more. We've done Monday and Tuesday. We have Wednesday and Thursday. Please continue to bear with us, continue to support us, and I'm sure by the time we end up on Thursday, you will really convince yourself that you have had a memorable training period. Thank you very much.
A round of applause for him. Then now, a round of applause for yourselves. Thank you. It's not easy. So we welcome once again. Yesterday was representing the president. Today he's here in his capacity, Vice President, Professional Development, Nigerian Society of Engineers, Engineer Dauda Aluya Okoduga, FNSC. I saw Engineer Dauda Musa, FNSC, National ESCO member. Okay. So ladies and gentlemen, can we please be upstanding? We'll recite together the third stanza of the national anthem as our closing prayer, and then our launch prayer. Together we pray, O God of all creation, grant these our one request. Help us to build a nation where no man is oppressed, and so with peace and plenty, Nigeria may be blessed. Amen. Thank you. Enjoy your lunch in batches. Thank you.